Most visitors to the William A Irvin have seen the steam turbine engine room that once propelled this ship. But the engine room is only half of the system. Hidden within the ship is a whole other world of machinery that made it all possible. Hello, I'm Jason, and you're watching Steam, Electricity, and Propulsion. Leaving the museum's gift shop, we walk down one of the ship's tunnels towards the stern. Crewmen quartered in the front of the ship could use this tunnel to safely get to the back of the ship during a storm. When the Irvin was built in 1938, this was an up-to-date safety feature which some older ships didn't have. At the end of the tunnel, we arrive in the boiler room that powered the ship's engine. The first thing we see are dampers to control airflow through the boiler. They could either be hand cranked or automatically controlled by these pneumatic cylinders. These small electric motors drove the forced draft fans. Air from the fans was sent through an air heater located in the boiler outlet before being delivered to the fireboxes. At the very top of the boiler room is another pair of DC motor-driven fans. These fans drew exhaust gases out of the boilers to maintain proper airflow. The motors powering the induced draft fans are rated for 30 horsepower at up to 1,500 RPM and operate on 240 volts DC. Moving down to the middle boiler room level, we get a closer look at the air heater. Here, we are also near the bottom of the coal bunkers, where chutes would drop coal onto short conveyors that fed the boiler stokers. Between the bunker chutes is a doorway leading directly into the engine room. Now let's see how coal is actually fed into the boilers. Here on the lower engine room deck, we see the boiler furnaces. A plaque on the side identifies these units as Foster Wheeler D-type boilers. When the Irvin was built in 1938, these boilers were modern and fuel efficient. These are fire-right stokers which can precisely meter and distribute coal into the furnace. Coal from the bunkers was carried down by conveyors, filling the stoker hoppers. A reciprocating feed plate then controlled exactly how much fuel entered the furnace. As the engine speed changes, the amount of fuel also must change. Rather than driving the feeder directly, an eccentric operated a separate lever that moved between a latch and an adjustable wedge. A pneumatic cylinder adjusted this linkage through a long feed rate shaft. At the end of the shaft, a cam moved a wedge control rod, changing the amount of slack between the moving feeder levers. This varied the amount of coal delivered to the furnace. Controlling the amount of coal was only part of the challenge. How was it spread evenly across the grate? A A small motor drives the stokers and causes rotary beaters under the feeders to scatter coal into the firebox. This pipe was part of the ash ejector system, which would discharge ash over the side. Behind the boiler room is another part of the engine room that most visitors never get to see. This is the lower engine room, home to many of the critical auxiliary pumps and condensers. On the boiler room wall, we see ballast water gauges and a massive 100 horsepower pump motor. These ballast pumps ran on 240 volt DC, which was standard for marine electricity in the era. In front of the condenser, we see a condensate pump and a large cooling water pump, which are all electric and therefore modern. Here's one of the few steam-powered auxiliaries, a turbo coffin feedwater pump. This steam piston pump is likely a backup to one of the main pumps. Farther behind the circulating pumps is the condenser, where exhaust steam from the turbine was cooled back into water. As the steam condensed, it created a vacuum that allowed the turbine to extract more energy from the expanding steam. Also located here is the high-pressure turbine casing. We can see the nozzle valves. At reduced speed, some valves were closed to maintain about 400 psi behind the remaining open nozzles. This machinery purifies and pumps lube oil for the main engine. In the back of the engine room, above the propeller shaft, we see small condensers for the turbo generators above. This small electric circulating pump sends seawater through the condenser tubes. Condensed steam inside the shell collects in the hot well where it is removed by another small pump. Now we have seen most of the overlooked machinery in the lower engine room. But let's move to the other end of the ship to see another area most visitors never get to see. In the bow, we enter the crew bathroom located between two bedrooms. These forward crew quarters are off limits to regular guests, but this isn't what we are here to see. This large machine is the windlass, which raises and lowers the ship's anchor. This grooved wheel grips the anchor chain and feeds it into the chain locker. Unlike older steamships, this machine is powered by a large electric motor rather than a steam engine. Now let's look at the top of the aft deck house. Here we find water tanks and diesel fuel tanks. The diesel fuel supplied the emergency generator, which we will look at later. We also see the boiler room vents in a coal bunker hatch behind the smokestack. Directly beneath us are the draft fans and coal bunker. Now, you've probably seen the engine room before, but let's take a closer look at the ship's generators and power steering. In the back are two turbine generators that supplied all of the auxiliary motors with 240 volt direct current. Each 290 horsepower steam turbine operated at 10,000 RPM, while a reduction gearbox lowered the speed to 1,200 RPM for the 200 kilowatt dynamo. The generators ran at a constant speed to handle sudden changes in load, requiring a governor. This rod likely operated a pilot valve that directed pressurized oil to a control cylinder, which moved the steam throttle valve and controlled the turbine speed. The turbine nozzle valves were adjusted by hand, unlike more advanced generator turbines with automatic nozzle control. This panel is where the generators are controlled. There are voltage gauges and circuit breakers, including the main generator breakers. If these were accidentally tripped, all the lights and electric auxiliaries would be disconnected from the running generator, causing a blackout. In the event of a power outage, there's a small diesel generator in the top of the engine room. It's a 3-cylinder, 4-stroke Fairbanks Morse diesel. These paper chart recorders monitored steam consumption, and these buttons were used to operate various auxiliary pumps throughout the engine room. The Irvin was one of the first freighters to have electric hydraulic steering. It appears that the movement of the steering wheel actuated this cylinder, which controlled a hydraulic relay. The relay would then control the motor-driven oil pump and direct hydraulic pressure to the rudder cylinders. The gear on the tiller provided movement feedback to the relay, stopping the oil flow once the desired rudder angle was reached. Hidden behind piping and feed water heaters are some DC motor-powered air compressors. We also find a sanitary water pressure pump which supplied water pressure for the ship's toilets, showers, and sinks. In the upper engine room is an evaporator which used steam to boil and distill lake water for make-up feed water. This MG unit converted the ship's DC power to AC for the radar, and the induction motor may have also been used to convert shore power to DC for cold starts. These are balancer sets, another important but overlooked piece of equipment. It kept both 120 volt circuits of the ship's 3-wire system balanced. Neutral current passed through series field coils, causing one DC machine to act as a generator while the other acted as a motor to keep both voltages nearly equal. This large tank might be a deaerator or condensate storage tank. We head through this tunnel beside the coal bunker back into the boiler room. Behind the boilers are diamond soot blowers that clean the economizers. Also located here are air casings that directed heated air from the flue gas air heaters beneath the grates. Behind the right boiler is a blower for secondary air. This air fed both boilers through a duct and would burn volatile gases above the fire to prevent black smoke. These gauges would indicate air pressure throughout the boiler. Behind the left boiler is another boiler. This vertical fire tube unit was used to keep the ship warm during winter layup. Up on the poop deck, there are some more crew quarters besides the induced draft fan room. The William A. Irvin's engine room is more than just a steam turbine and generators. Most visitors to the museum have no idea what kind of technology is hidden within this floating steam plant. Much like modern steamships, this steamer from 1938 has D-type boilers along with lots of electric auxiliary pumps and fans. If you learned something new, let me know down in the comments. And if you want to learn more about steamships, watch my video about the SS Badger's engine room.